Okay, I think it is live now, no? Okay. So welcome to NPTEL online course on machine learning and deep learning, fundamentals and applications. So this is the final live session of the course. So if you have any questions or if you have any doubts, you may ask me. I'm available for 1 hour. So up till now, we have covered the course, complete course. So it is a 12 weeks course on machine learning and deep learning. And if you have any questions, then you can ask me in this live session. So here I have seen some questions in the portal. So before replying these questions in the portal, and there are some questions in the Excel sheet. So first I will discuss about these questions, and after this I will answer your questions. So the first question here, I can see the first question. So the first question is by Sudha LR. So his question is, the logistic regression does not make any assumption about data distribution. Sir, is it true? You have discussed about Bernoulli distribution in logistic regression. Then what for the Bernoulli distribution? So the concept of the logistic regression is the classification, the binary classification. So either yes or no. And for the training of this, we have to consider this binomial distribution or the Bernoulli distribution, because the output is either yes or no. That is very similar to binary classification. So that is why this is important. That is the Bernoulli distribution. The second question is by R. Kumarsamy. Dear sir, how can we use GAN or DCNN for a one-dimensional signal? So this is a very good question. So for one-dimensional signal, we can apply the convolutional neural network or maybe the GAN. So for one-dimensional signal like the biomedical signal or in the speech signal, so what we can consider, and that one-dimensional convolution we can consider. So the convolution concept is very similar. We discussed the concept of the two-dimensional convolution. So if there is any problem in my audio? So I think now it is okay. So I discussed the concept of the two-dimensional convolution, the 2D convolution. So 1D convolution, the concept is very similar with the 2D convolution. So for 1D convolution, I can apply the same principle, that is the convolution principle. But the signal is the one-dimensional signal, like the audio signal or maybe the speech signal, the biomedical signal. So I can apply one-dimensional convolution. So also what we can consider, suppose in case of the speech, so how to apply the convolution? So you can convert that speech signal into spectrogram. So that is nothing but the frequency information. So that means the signal can be converted into image, and that is called the spectrogram. So 1D signal, the speech signal can be converted into spectrogram that is similar to the image. And if I get the image, that is the spectrogram, then you can apply the convolution, the 2D convolution. That already I have discussed in the convolutional neural network. So that is the principle. In one dimensional, you can directly apply 1D convolution, but also you can consider the technique like if I consider the speech signal, the spectrogram, that is the frequency information is available in the spectrogram after having some transformations. So I'll be getting an image. I'll be getting an image corresponding to that signal, and you can apply the 2D convolution. So that is the question. The third question is from Dr. Sobik K. How does the activation function remembers which neuron is activated or not? So corresponding to this question, what I can answer, the activation function is not remembering. So input is compared with a particular threshold, and if the input value is greater than that particular threshold, then I will be getting the output in the corresponding node. So that is why it is not required to memorize. But if I consider suppose recurrent neural network, then there are some concepts like gate unit. So that I have not discussed about this in the recurrent neural network, but we may also consider. But in case of the simple artificial neural network, what is the function of the activation function? That is nothing but the thresholding function. So that is actually the input is compared. Input means the sum signal is compared with the threshold. And if the sum signal is greater than the threshold, then corresponding to this, I am getting the output from the neuron. That is the neuron output. So that is the concept of the artificial neural network. So Saurabh Biswas, I think my voice is now okay. I don't know about this. And another question is by another question is the sir, final exam should be objective type. Yes, the final question, the final exam will be objective type, and I think that may not be a difficult one. So like the assignment questions, you can prepare, and there will be 50 questions. So total marks will be 100 marks. So it will be MCQ type. So that is not a problem. So these are the questions in the Excel sheet I have obtained. I have seen the questions. And if you have any questions, then you can put me in this live session. So in the chat box, you can post your questions, and I will try to answer the questions. So R. Kumarasamy, thank you. I think I have explained this concept of the 1D convolution. So Saurabh Biswas, he is writing, is it possible to do classification in deep learning with feature extraction from the limited number of, what you are writing, the limited samples? Is it possible to do classification in deep learning with feature extraction from the limited samples? No, in case of the deep learning, the one problem is that we need the huge amount of training data. So that is the problem of the deep learning. So if I consider huge number of training samples, then it is possible to extract important features from the input image or from the input signal. So if I have limited number of training samples, maybe I can consider traditional machine learning techniques. The deep learning techniques has this problem, and the problem is that we need the huge amount of training data or the training samples, and from this we can extract important information with the help of the convolution. So that concept already I have explained in my class. So Saurabh again, he's writing, is there is any specific procedure to be followed to validate image captured using cameras in a custom dataset used for deep learning applications? No, there is no specific procedures to be followed to validate image captured using the cameras in a custom dataset. No, if I have more variations in the dataset, that is good actually. So that is actually the objective. If I have the more variations in the training dataset, then my system or my network can learn many things. So that is why the data augmentation procedure is there. Suppose I have one image. I can rotate that image, I can do the scaling, I can do many transformations, and these images I can consider for the training. So then my model will be good because I am considering many such cases, and because of these cases, different cases, my model will be robust. So that is why there is no specific procedure to be followed during the training. So that data augmentation procedure is like this. So we can consider different types of transformation. So from a single image or from some images, with the help of the data augmentation techniques, I will be getting a number of images. That means I will be getting number of images for the training, and that is actually good. So Sanjeev Sarwan, when will be the final exam going to be held? So you see the NPTEL website. I think it will be in the month of October. So I don't have this information. I have not seen the website. So you see the website of the NPTEL, then you can understand. We can get the information, that is the date of the examination. So Saurabh Biswas, he is writing how to generate a set of what you're writing, set of how to get a set of parameter, I think parameters, a paired image dataset using deep learning models. So I'm not getting this question. What is the meaning of this? How to generate a set of paired image dataset? What do you mean by paired image dataset? Is it like a stereo vision or stereo image? So what do you mean by the paired image dataset? What is the paired image dataset? Deep learning models can be considered or can be used for generating new images. Like I explained the concept of the GAN, the adversarial network, the generative adversarial network. So we can generate number of images with a GAN. So I explained the concept of the GAN, and already I have explained so how to get the new images with the help of the GAN. So another question from Vishal Sahu, sir, how residual net able to bypass vanishing gradient problem? That part not understand. Because in case of the residual network, we are bypassing some of the layers. So vanishing gradient problem is because of the number of layers. So if I consider number of layers, because we have to back propagate the error, that means we have to back propagate the gradient. So if I do the back propagation of the gradient, so if I consider many layers, then we have to do the multiplications. And because of these multiplications, the gradient value will go on decreasing, and that is the problem of the vanishing gradient. So that is why we consider the bypassing technique. So there is another question in that one. What is the question? So and that provide some additional notes for solving the problems. So I think for solving the problems, you have to see maybe in the internet also some of the problems may be available. So, but it is very difficult to get the problems in the books. So that is why just see in the internet, you can see some problems like suppose logistic regression, the decision trees, the ensemble classification techniques. So in the books, actually in the Duda and Hard book, it is not easy to get the problems. So if you understand the concept, then I think the problem solving is not a big problem. But only thing is you have to understand the concepts. So Kumarasamy, Dr. Sir, please share program sheets. So what is actually program sheet? I could not understand. What is the program sheet? Please share program sheets. What is the program sheet? So have you mentioned about this Python program? So the Python programming PPTs we can upload. So I think we have uploaded all the course materials like the PPTs in up to week number 11. Week number 12 also we can upload. Video of some applications are given. Okay, so that means you need the PPT, the code of this. Okay, so okay, then we'll upload that PPTs. The PPTs of the that codes mainly one is the convolutional neural network, GAN, unit. So okay, I will upload this one. So Saurabh, again, he's writing, how does dropout change the loss landscape in the context of neural network? So what is the under the question? I could not understand. What do you mean by loss landscape? I think your question you should explain me properly. I'm not getting the question. What is the dropout? I understand the dropout in the convolutional neural network. And what is the loss landscape? So one question is kindly share the final exam pattern. The final exam pattern will be the same as that of the assignments. So what about the weekly assignments you have you have seen or you are getting in the weekly assignments? It will be similar objective type questions. And as compared to your assignments, I think the NSIM will be the last exam will be final exam will be easy because in case of the your assignments you can see some of the problems, but in the final exam you may expect some easy questions like theory based questions. So it is the MCQ type questions, MCQ, the objective type questions. So yes, the dropout change the dropout change the loss surface. Yes, because of the dropout, you can see we are losing some information. So that is the actually the meaning of this. We are losing some information, but why actually we are considering the dropout? That point also it is important. So Saurabh, you write the question properly. So what is actually the meaning of this? So you send me you can send me the questions by mail. Then if you send at least 1 or 2 questions, then we can reply. Otherwise, also beyond this live session, also you can interact with my TAs. You know the mail ID of the TAs. Also, you know my mail ID. So you fix a time. with the TS, and whatever you have the questions, they can answer. So, okay, if you have any questions, then you can put in the chat box. So this is the final live session of this course. So in the exam, you will be getting the objective type questions, the MCQ type questions. And if you see all the videos and if you read the books, then I think it is not a difficult. So easily you will get the good marks in the final exam.
बकचोदी मत करो ना. कैमरा ऑन है.
So Saurabh Biswas, that you mentioned about what the question? How does dropout change the loss landscape? So already we discussed about this loss landscape or the loss surface. That is actually number of minimum points. So that you can see which techniques are used to improve the accuracy of the deep learning models, compressing neural networks. Again, the question is not clear actually. That just I think this some of the questions you are not putting correctly. Which techniques are used to improve the accuracy of deep learning models, compressing neural networks? So because we discussed that how to compress the neural network by considering the concept of the convolution. So you can reduce the number of parameters of the neural network by considering the convolution, by considering the concept of the stride, and by considering the concept of the pooling, and also by considering the sharing of the weights. So by considering these techniques, we can compress neural networks. I think that is the you are expecting that one. That is by convolutional neural network, because in a convolution we can reduce the number of parameters by considering the concept of the stride, by considering the concept of the pooling, and by considering the concept of the sharing of the weights. So we can reduce the number of parameters. That means we can compress the neural networks. This loss surface is actually the concept of the number of minimum points. So one question is, we refer your lectures in PPT. Apart from that, what you are writing? Apart from that, we are referring Alpine book for ML. Any book. Also you can see the book by Duda and Hart. So another book already I told you that for the initial part of the course, like the Bayesian decision making, the parameter estimation, maximum likelihood Bayesian estimation, and concept of the hidden Markov model, expectation maximization algorithm. So for this also you can see the book by Duda and Hart. That is a very good book, but this book is also very good. So I think that will be sufficient. So you see my lectures and also see the books by Duda and Hart. And this book, the book by Alpidine, that is also very good. So this book also you can see. And I think that will be sufficient for the machine learning. So if you have any questions, then you can post in the chat box of the YouTube. Then I will try to answer. So
So
Saurabh is
Saurabh is
again
just
another
again another
question, but
question,
these
but these
questions are
questions are actually
not
not
related
related to
each
each
other.
other.
So you are
So
not
you are not
focusing in one
focusing in one
direction.
direction.
Sometimes you are
Sometimes you
asking
are
about the
asking about the
camera,
camera, again
again
you
you
are
are asking
asking
from
from
some
some
another
other
concept,
concept,
again
again
you
you
are
are
asking some
asking
another
some another
questions.
questions.
That your
That your
questions are not
questions are not
focused in a
focused in a
particular
particular
direction.
direction.
So if you
So if
want
you
to
want
do
to do
research in a
research in a
particular
particular
direction, better
direction,
to be
better to be
focused in
focused in
particular
particular
direction.
direction.
So
So
this question
this
is
question
about
is
how
about how
can we
can
classify
we
building
classify building
materials
materials
such as
such as
various cement
various cement
using
using.
three spectral reflections curve using deep learning. Yes, this is about the image processing. So materials such as cement quality. Cement quality that from the features, like maybe color feature also you can consider. That is actually the spectral reflectance. So if you consider, hello. So if you consider this features like the color features or the texture features, and you mention about the spectral reflectance, so that you can consider as features. And if you consider this as an image, then we can apply the convolutional neural network to see the quality of the materials like cement quality. So what are the features you need to consider? That you have to first be sure about that. What are the features you need to consider? So if you consider that one, that these are the features I want to consider, then I think the problem will be simple. So any problem in the econ, I think so that your question is how to classify building materials such as cement. So that means the quality of the cements you are mentioning. So for this, what you need to consider, you have to consider what type of features you need to consider for the cement classification. So I feel maybe the color may be a feature, or maybe some granularity, or maybe something like the texture feature, or maybe some type of features you can consider. And based on this, you can apply the deep learning techniques. So if you have any questions, then you can put in the chat box. So better to focus in one direction. So if you want to do in a particular direction, better to focus in a particular direction. So why does the performance of the deep learning improve as more data is fed into it? Because in case of the deep learning, the main objective is to how to extract features. So if I have the huge number of training samples, then you can extract features. The important information from the input image or maybe from the input signal. So that is why you need the huge amount of training data. Then only the convolutional system, the convolution, because you are considering the concept of the convolution. Then only the convolutional system, the convolution system can extract important features. So suppose if I consider only 2-3 images, but image has many features like the high frequency features, the low frequency, mid frequency information. But if I consider only suppose only one or two filters, then you cannot extract all the important information from the input image. So I have to consider multiple filters, and I have to consider the many input images so that I can extract important information or the features from the input images. So Vishal sir, that already I explained the concept of the skip connection. So I have already explained the concept of the skip connection in case of the residual network. So the problem is because of the problem of the vanishing gradient or the exploding gradient. So if I consider the problem of the vanishing gradient, so what is happening during the backpropagation training, I have to backpropagate the gradient. And if I consider the sigmoidal function, so if I consider the derivative of a sigmoidal function, that is equal to 1/4. That's the maximum value. So that value is 1/4. That already I have explained. So if I multiply 1/4, 1/4, 1/4 multiple times, then this value will go on decreasing. That means the gradient value will go on decreasing. And if I consider the initial layers, that will not be updated. So there will not be any update. So to consider this issue, maybe we can skip some of the layers. So if I consider some of the layers, then somehow the problem of the vanishing gradient can be minimized. I should not say that it can be eliminated, but it can be minimized if I consider the skip connection. So you see my mathematical explanation. So in my that PPT or in my video lectures, I have shown two paths. One is the direct path, another one is the skip connection. So what is happening in case of the direct path and what is happening in the skip connection? So that you can see. And skip connection is mainly we are considering the problem of the vanishing gradient. So we are avoiding some of the layers. And what is the learning in case of the skip connection? And what is the learning in case of the direct connection? So that concept I have explained in my video lecture. So that you can see in case of the residual network. The residual network I have explained the concept of the skip connection. So the sigmoid function, if I take the derivative of the sigmoid function, after this, if I take the maximum value, the maximum of the derivative, then it will be equal to 1/4. So this is a fractional number, that is 0.25. So if I multiply 0.25 into 0.25 like this, if I multiply number, then the number will go on decreasing. So that is the problem of the vanishing gradient. So if you have any questions, then you can put in the chat box. Okay, there is another question. What is this question? Vishal Sao, there is another question, sir. What is the leaky ReLU? Okay. So you see the ReLU function. In ReLU function, actually, the positive value, actually, it is the linear function. If you see the linear one, and corresponding to negative, it is a flat. So it is 0. But in case of the leaky ReLU, you have the negative slope. So for the positive value, it is same as that of the ReLU. For the negative values, in case of the ReLU, we consider the you will get the negative, the slight negative it is considered. The slightly negative slope is considered in case of the leaky ReLU. So otherwise, the fundamentally this ReLU and the leaky ReLU is same. In case of the ReLU, for the negative values, I have the flat function. But for the leaky ReLU, I am considering the slightly negative slope. That is the difference between the leaky ReLU and the normal ReLU. So you can see this function, ReLU function, in the internet. What is the ReLU function and what is the leaky ReLU function? So that is nothing but the same as that of the ReLU, but we are not considering the path corresponding to the negative value. We are considering slightly negative slope. We are considering in case of the negative values. So I think Vishal, you understand the concept of the leaky ReLU. And the difference already I have mentioned. So suppose if the data has the noisy points, the noisy data, or maybe the outliers, then the leaky ReLU is better than the normal ReLU. Because if I consider the normal ReLU, I'll be losing important information. But in case of the leaky ReLU, we are considering also the negative values. So suppose the data has noises or maybe the outliers, then corresponding to this, I'll be getting 0 in case of the ReLU. Also, but that means we are losing important information. So that is why for such cases, we can consider leaky ReLU function. So could you implement a feature engineering techniques help deep learning algorithm perform better than with the complex data? So could implementation of the feature engineering techniques help deep learning algorithms perform better? Yes. So feature engineering techniques also in many recent papers, they are considering the feature engineering techniques along with the deep learning techniques. So in this case, sometimes for the complex data, it is useful because you will be getting additional features that is the feature engineering techniques we can employ along with the deep learning techniques. So some of the papers in speech recognition I have seen in NLP also. You can see the natural language processing. You can see some papers where they consider the feature engineering techniques. So initially the features can be extracted by some traditional method, and after this also we can apply the deep learning techniques. So if you have any questions, then again you can put in the chat box. So I'm available up to 4 p.m. because this is 1 hour live session of this course. So if you have any questions, then you can put. So Saurabh, have you seen this portion of the course, the deep learning? Because it is not possible to discuss all the important things or the important deep learning techniques in this course, but I tried to discuss some of the important deep learning techniques like the convolutional neural networks and different types of networks like Google net, residual net, and also some concept like GAN, UNet. So is it okay? And also the concept of the vanishing gradient. So these concepts I have included, but it is not possible to discuss all the concepts. So maybe in my next deep learning course of the 12 weeks course, then only the deep learning techniques can be discussed. Okay, how to downsize a large pre-trained CNN model to a smaller size without losing performance. So in this case, maybe one technique, the number of layers we can consider more number. Okay, I think for deep learning, separate course will be required. Yes, because this is a combined course on machine learning and deep learning, so it is not possible to discuss all the things. So maybe the next course, deep learning, complete deep learning course, I am proposing now. So let us see in the next year, because by that time many things, the new things are coming, not only the convolutional things, but currently there are many things like vision transformer and generative models, some generative new models. So these concepts are coming now. So and also the like some of the momentum techniques, momentum optimizer, RMS Prof. So these techniques actually I could not discuss. So maybe we can see that this course in this content in the next. So this course, yes, because in this course most of the material is covered in ML. So in ML portion, I tried to cover in the important things, so that at least you can understand the books. So if you read books, then at least you can understand, because now mathematical concepts are okay. So if you have mathematical concept, then you can understand the books and also the research papers. So I think up to this portion, that because the Bayesian estimation, the Bayesian decision making, and also the concept of the the parameter estimation, these are very important concepts. And also the concept of the regression, logistic regression, binary decision trees, and the concept of the hidden Markov model, expectation maximization algorithm, mean shift clustering, k-means clustering, fuzzy. All these are very important in machine learning. So if you understand this concept, I think for understanding of the books, or you can understand the research papers, that will be very easy in this case. And deep learning now, I think the concepts are not so difficult as that of the machine learning, because only the slight changes in the deep learning models. The basic concept is the convolutional neural network. The convolutional neural network, that is the basic concept. And if you see the development is not so difficult. If you read the concept of the, suppose, Google net, residual net, the concept of the momentum optimizer. So these concepts are not so mathematical. So these are very easy to understand, deep learning techniques, as compared to machine learning techniques. In machine learning, the problem is the mathematical background. You should have a good mathematical background. Then only you can understand the machine learning techniques. But in the deep learning, I think only the logical understanding and only some of the mathematical things you need to understand, mainly the loss function, what is the momentum. Otherwise, it is from the architecture point of view, it is very easy to understand these concepts, the deep learning. So Saurabh, if you have any questions, then you can put here. Otherwise, you have the mail IDs of the TAs, so you contact them and you can discuss some of the research topics. And better to focus in only one direction, one or two directions. Because if you focus in one direction, then you can go into the depth. So, sir, in machine learning and deep learning, major difference is the feature extraction and rest. Typically same as it is. Yes, the feature extraction is the main in case of the CNN and the traditional machine learning things. And in case of the machine learning, first we extract features, and after this we apply the classifiers. But in case of the deep learning techniques, simultaneously we are extracting features and we do the classification. So that is the difference between the convolutional neural network and the machine learning techniques. But there are many other deep learning techniques like GAN. The concept is slightly different. So GAN can be used for generating new images that you can see in my video. So that cannot be, it is very difficult to consider in machine learning. So with the help of the GAN, we can generate new images. So that is nothing but the image to image transformation also you can do. But in machine learning, that will be quite difficult. That is the generative models mainly. So from that point of view, it is different. But if I consider simple convolutional neural network, that what you have explained, that is correct. So anyhow, this my new book is coming on deep learning in the next year by January, February. Then you can see this deep learning algorithm. Okay, so if you have any questions, can the discriminator in auxiliary classifier discriminator in auxiliary classifier generative adversarial network be used for multi classification? Yes, yes. So yes, it can be used for multi-class classification. So we have one auxiliary classifier in case of this advanced network. That is actually the auxiliary classifier generative adversarial networks. This is a very new concept, and it can be used for the classification. So you can read the corresponding paper. So some of the research papers are coming, and one of my student, the PhD student, he is also working in this domain. So for gesture recognition, that he tried this concept is from another NIT actually. So auxiliary classifier generative adversarial network to be used for multi-classification. Yes, you can see some of the papers. Some of the recent papers are available on this topic.
Hello, sir. Swati here. I have some question. I heard about this one-shot learning. So, what is the difference in these two? Also, I know that one-shot learning requires less data. But how can I compare typical traditional deep learning model and then model which is trained using one-shot learning?
So for understanding of the deep learning algorithms, it is not so difficult. Because if you understand the basic concepts like generative models, the convolutional neural network, the concept of the gradient descent algorithm, the concept of the vanishing gradient, the concept of the residual network, the concept of the skip connection, concept of the transfer learning, and concept of the dropout. So if you understand this concept, I think that is not so difficult to understand actually the deep learning algorithms. So
No,
what
no.
is transfer learning? What is the data augmentation? What is the concept of the dropout? What is the concept of the skip connection? So these are the fundamental concepts. So you have to understand then many things you can understand because it is not a difficult one.
Okay, I want to understand in terms of accuracy because since those models are trained using less data, how reliable those models are as compared to deep learning, traditional deep learning models.
So results of sir, all these Google Net, residual net are the examples of unsupervised learning. No, no, these are the supervised learning. These are the examples of the not unsupervised. These are supervised. Because for the training of the Google Net, we consider the backpropagation training. So these are actually the supervised. So I think we can conclude this session almost complete. So Vishal sir, you write about this Google Net, residual net, no, these are the supervised learning techniques. So another question: what degree of difference does validation and training loss need to have to be called for a good fit? So that actually depends on the application. So for a application, like suppose in medical image analysis, so for this you have to be considered a good fit, very good fit. But for some other applications, that you can compromise also. So you have to see the application point of view. So the difference between the validation and the training loss, that many times it considered based on the applications. So which loss function you are using, that is also important. The loss function, defining the loss function for a particular application. So nowadays, actually, the papers, the research papers in case of the deep learning, there is very difficult to sense many things in the deep learning. In case of the simple machine learning or in case of the computer vision, you can propose many mathematical things. But in the deep learning, it is very difficult to propose new things. So what are the modifications in the existing papers? If you see the people are proposing only the loss function, so that is the contribution. So to give new contribution, to show the new novelty, to show the novelty in the research paper, it is very difficult. So if you see the existing papers or all these papers actually mainly focus on developing the loss function only, and only some of the structures of the deep networks. But significant changes, it is not possible. So people are using the same structures in deep learning, and only some modifications like the modifications in the loss function they are proposing. But in other conventional techniques like statistical techniques, people are doing the proposing many mathematical things. In computer vision also many things, because these are the classical computer vision techniques. So statistical things they are proposing. So, but in deep learning, people cannot do many contribution. Like it is very difficult to show novelty. So that is why I think they are mainly considering the loss function. So Saurabh, sir, recently I published my paper in international conference. I will share it. Yes, very good. So this is very good. So you are trying to publish papers. So you can share the paper with me. So it is okay. Very good. Some of my papers you can see in my website also. We have published some of the papers, but I don't know these papers are relevant to your field or your research field, or that I do not know. But you have to see my publications, then you can understand these are my research domains, and if it is matching with your research domain, then you can discuss with me or my students. So I think we can conclude this session. So already 1 hour is over. So there may be another live session. Okay, Saurabh, okay. So one day you can discuss with my team, my students, and if I available, I can discuss with you also. Okay, okay, okay then. Okay, then I will conclude this session. This is the last session of the course, Machine Learning and Deep Learning, Fundamentals and Applications. So all the best for your final examination. I feel it is not a difficult examination because mainly the MCQ type questions. And if you see my videos and if you see the materials, then I think it is not a difficult examination. So all the best for your examination. Thank you. So I'm leaving now.